back. So this session will be about Make and CMake. Those are tools that allow you to compile easier your project. So it's in two parts, Make first and then CMake. I will go very fast on Make because I want to focus more on CMake. I think it's some more powerful tools, but that also comes with more features and takes more time to explain. So yeah, Make and Makefile. Makefile is the name of the file you use to interact with Make. Okay, we use that in a short while. We're used to automate the compiling of small to medium projects. When you're used to like CMake, for example, you want to use Makefile as a rule, but it's important to know how it works so you understand how we can automate compiling. I based all this session on two tutorials. The first one is makefiletutorial.com. It's really well made. It's an official tutorial. Okay, so I did not invent anything here, and it's easy to learn, easy to follow. It's well made. So if you after this, if you're more still interested in go further on that, I advise you to go check it out. So to get started, I'd like you to connect to a cluster. I tried it on Method 4 and Makefile, so it will work on both. Try to go on the Method 4 since we are actually here. And, the idea is that you're gonna there is an archive there, the cc/prod/CMake.zip, and you unzip it into your own directory. It's -d.0. Then you go to the first step, the first exercise of this session, which is called step 0. Is everyone okay? Is there any problem? No. So the main command you're gonna use with Makefiles is make. So it's a simple program called make. So by default, here you have the first thing you have to do is to, once you moved to that directory, just type make, and that program will do a lot of things. We are going to see that together. You can, if you want, you can play a little bit with it and just follow the few instructions that should print on the screen when you type make. But to give you a basic understanding of how it works, if you open the Makefile with Vim or manual, you will see a bunch of rules that are written like this. So I don't know if I'm going perhaps a bit too fast. You're still, I guess, playing with me. Okay. So as I was saying, you can see a Makefile a bit like a to-do list, with each task, with each to-do being a little bit as having that syntax. So there is targets, prerequisites, and comments. Okay. So that's the three ingredients for rule. The targets. Target is the name of the rule. So if you want to make a specific target, you can just type make and the name of the target. You need to be, that's something that I encountered some problems with when I was actually. So Makefile use tabs, not the 4 spaces that are commonly use more fundamental. This is important. So Make is meant for smart compiling. This is actually the strength of Make. That's why we use Makefile. Is that Make will not try to compile something that is considered up to date, which means that if you have a large project with lots of binaries and you want to compile only the parts you actually modified, Make allows you to take care of that and to do it automatically without the need of recompiling everything or without the need to target specifically what you need. Now the question, of course, is how does it do? Yeah, some emojis. So the rule is a task of the Makefile. So each of those is that is a rule. Each of those tasks is a rule. That is the name of a rule. It's also the name of the target, the name of the file that should be produced by that specific rule. And prerequisites is either the name of an existing file or the name of the targets to be executed. If it's neither of them, then you have an error. And the idea here is that you may have targets that have as prerequisites some files that are to be produced, so they don't there already, but they will be produced. For example, .o if you compile C or C++. If Makefile sees a target that has that name, it will assume that it should produce that file, and then it will execute that rule and produce eventually the file, and then use that file in the next. Okay. So it knows what file to compile, what rule to execute based on timestamps. So if you're not familiar with that concept, it's very simple. Actually, it's a bit like a label on each of your files with tags. Okay, here Make will check the last time the file has been modified. And if the last time the file has been modified is is smaller, I mean, if some file is more recent than a target, then it will compile the target. Because of course, if some source file has been modified after the next compiling of the targets, most probably it means that the code has changed. Okay. Otherwise, it will not do it. Okay. So this gives the importance. This gives a lot of importance to prerequisites. You may think that a prerequisite should be another rule. It's not exactly true. It's either another rule, but it also should be the files that you actually use. For example, if you compile some exec here that uses some header file2.h, I perhaps want to recompile every time there is a change on file2.h. And if the source file of some exec is file1.c, then I obviously want some exec to be recompiled every time I change the code in file1.c. If I don't put them, those two, file1.c and file2.h, this rule will still compile once, because it will execute the line that is just below. So basically, file1.c dash rules and exec will be triggered because there is no file name some exec. It's two conditions at the end of the slide. So if there is no file bearing that name, of course, Makefile will execute that rule. If there is, it will check the prerequisites. If there is no prerequisites, it won't do anything. So it's important to actually keep your files as a prerequisite, the files that are needed, that you want to be checked for the timestamps as prerequisites. So, good practice. We should have one rule per source file. So .c, .cc, .cpp, .cxx. Here I just list some C extensions. Of course, you can do this with pretty much anything. If you look inside of the file that there is on the cluster, the Makefile on the cluster, you will see that actually there is not even a compiler being used here, just to play just some echo comments. So you can, of course, you can use Fortran, for example. You can even launch Python scripts if you want. It's kind of a glorified bash script. I mean, it's not nice of me to say that, but it's really okay. So you can do pretty much whatever you want. But if you use the compiler, you should have one rule per source file. So you produce one binary per source file, and then you link it together as the main target when you produce your actual program. Yeah, the first rule is always equal. So when you type make without anything, the first rule counter is the one that is executed. So you should use it as a main rule. Usually it's called all. Okay. And it's a good practice to have a rule called clean, where you remove every intermediary binary file which is produced. That's it. As I said, I will go fast. If you're interested, Makefile are very useful if you want to start a very small project. If you're interested, go on that link. It's easy to follow. Okay? So because it's easy to follow, I won't go further on that because we still have a lot to do. No. Is there any question on Make specifically? No? Okay. Yes?
Practice. Yep. First line.
Sorry, which one?
First line.
First line. Okay, you should have one rule per .c that line.
Yes.
Those are source code files. Okay. So if I type some code in .c file, for example. Okay. Imagine I write a program in C. I would type the code in some file that has an extension with .c.
Okay.
Then if I want to compile it, I need to have one rule per file. So if I have two .c files, I should have two rules, one for each. Okay? It's better that way. Make won't forbid you to have more than one .c file on as prerequisites, but the risk is that you just get lost in what you do there. So it's better to have one rule per source file.
This is only for the C.
No, it's for pretty much everything. Just that I use C extensions example, but you can do that in Fortran. You can do that with everything you want.
Basically, every file you need to compile. We need to have a.
It's better. Yeah.
You don't use the template for that. By default.
You can, but it's in the advanced stages, and I want to move to CMake for time constraint using.
Sorry. Can you go back to the timestamps?
Sorry?
Can you go back to the timestamps?
Timestamps? Yeah.
Like here, this will only execute if file one, just to check that I understood. Like this will only execute if file 1 and file 2 has been either are not there or have been created before you execute the.
Okay. If there is no file called subexec, subexec is an executable, but on any Unix system, they exist on the file system, so you can see them as files. So if there is no file named subexec, that will be executed whatever else. Okay. If there is, what happens is that Make will check the timestamps of file.c and file1.c and file2.h. Okay. If those are more recent than subexec, then it will execute the rule. Actually, it goes even further because if you have the name of another rule that exists in Makefile, it will go to that other rule and check the prerequisites. And if need be, then we compile it and then we'll recursively back to here. And then, so it's one strength of Make is that if you have a lot of different rules, you change one tiny file that's actually dependency to pretty much everything else in the project, everything that needs to will be recompiled, even though the prerequisites or the files prerequisites are not have not been modified. Right? Okay. Anything else? Okay, so now for the CMake tutorial, here we're gonna spend a bit more time here. There is the official documentation. So this should be your source of proof. More than Stack Overflow, more than anything else, because you can write things that do work in CMake, but that actually not really good. And you have a lot of people that just tinker around on Stack Overflow. The best is to start to documentation. And again, CMake comes with a nice tutorial that is pretty long here. And I will not cover every steps because some steps are a bit advanced and probably out of the scope of research for industry, for example. That level of development requirements. You most certainly don't like it, at least now as researchers. So you can go by yourself and check the tutorial. So again, to get started, you already have everything you need in the archive you unzip on your session. So on the cluster, you should be on the directory step 0. If you just go up one level up. So if you just ICD dot, you should be in the CMake 3.27.9 directory. Here I will need to use the release to 2023B, and I need CMake and GCC. So you should type that, so you should build those modules. By the way, if you need the slides, they are on the Indico webpage. I just put it this morning, so if you check that yesterday evening. And then you enter the Git directory to the CMake 3.7.9, and here you have access to all the exercises we need. So we'll start with step 1, and first we will have a look in what is in step 1. So this is a very minimal example. I mean, so that is the most interesting to me. So we can see 3 files. So CMake lists.txt. This is the file that CMake uses to build a project. It's a little bit as a Makefile of Make, but here it's for CMake. And there is one file that we're going to see later. It's JSON by CMake, some sort of template for header in C. By the way, CMake works mainly for C and C++. Okay, so Makefile is a bit more generic. Here it's mainly for C and C++. And the last one, tutorial.cxx, this is your source file. Okay, so here we have the code. And for this small projects, example project, the code simply compute the square root of some number. Okay, so it's really not that important here since we are not focusing on how it is being built. Most of the slides from now on are going to have that layout. So I give you a target. The target is a file, and I give you a number of to-dos to make, and you should go to inside of this file and look at the to-dos, and we are going to see that together. At the beginning, I will take some time to explain the steps, and then you should go faster and faster. So the first thing to do is to set the minimal version of a CMake. This is, we always have to take care of versions in pretty much what we do in a cluster. So here, one thing that would work is to set the minimal version to an arbitrarily low value of CMake. It will work, but I advise you not to do it. For simple reason, on the cluster specifically, the version 3.7.9 is the version of CMake that comes with the release 2023B, but CMake exists without it. It's installed system-wide. So if you put a minimal version, it will not detect actually that you are using the lower version of CMake while you would want to use a higher version. For everything related to reproducibility, it's important for you to keep track of the version you use. And this is the version we use, so it's 3.7. So now, next step is to name your project. Okay, so every project needs to have a name. This horrible thing here is actually what you will see if you go on the documentation. Actually, quite horrible. It's not very nice. But so if you go on the documentation, you will see this kind of things. It basically just tells you what you can put there, and then you have a description of every possible options. Here, everything that is between square brackets is optional. So here, this is basically what we want to do. We want to name our projects, and we call it tutorial. And then we need to add an executable. So this is a third to it. And again, an executable, so you need to give it a name, and then you have optional sources. Okay. Here we call our executable tutorial, and the source is tutorial.cxx. Okay. So this is basically all you need to do to write a very minimal CMake. CMake is.txt. And now, now we want to build and run a project. So you need to first, well, you don't have to do it, but I would strongly advise you to do it. You need to create a build directory. So every file that is produced by CMake is written on that directory. So you can, afterward, you can just remove the whole directory and regenerate it again if for some reason you have some issues at some point in the build. So here you make a directory called build1, and then you instruct CMake to to generate the project to be built. Okay? So it will not touch your source code. It will just copy it to the right place, generate everything that needs to be generated, and then build it in place. Okay? So it does not touch your source code. So the dash capital S and dash capital D for paths. So you instruct CMake to build in build1 using the source in step 1. Okay. So when you do that, you generate the files, and then you build your project, CMake dash build, and then you give the directory where CMake should build. Here's build1. Okay. Now the compiling is done. After that step, the compiling is done. Is everything okay? Yes.
The CMake-S step 1 must be run in the parent of step 1.
Yes.
And the CMake data build 1 in the parent.
Yeah, and I assume the parent of both are the same. You should be on the CMake 3.27.9 directory.
So the build 1 should be sibling to step 1.
Yeah. So you shouldn't need to type cd at any moment, actually. So the first box of code here is to compile your projects. The second one is to run the program. So the basic usage is type the name of the program with / to the program, and then give it a number and choose the square root. Okay. Do everyone reach a point? Okay. So this is a very minimal example on how to use CMake. If you want, you can have a look inside of build1, and you will see that actually what CMake does is generating a Makefile. So if you type ls build1, you will see a bunch of files that are generated. And CMake does not compile by itself. Basically, just writes a Makefile that is run using Make. So it's how it works inside. So so far we know how to make a minimal example, and we have to build the projects automatically by generating a Makefile. Now we're going to get more into it. So if I want to use newer C code, here it's to do 4 to 5. For now, I've been using C++ 98, which is pretty old. Let's say I want to move to a newer version, slightly newer version, C++ 11. And to do that, I want to use some library, S2D, which is a parser basically, say string to double, rather than A to F, which is hard to use like this. And when you reach that point, you should have a problem. Yes,
Sorry, but I get lost.
you got lost.
Quite in the beginning. I was like in the CMake list. So we could go a bit lower and we could help.
What's here? This part?
Yeah.
Did you do the first two? Am I globally going too fast?
Yes.
Ah, sorry. Okay. You need to communicate with me. Otherwise, I don't know.
Yeah, sorry. Okay, so you want to do the CMake folder, you go to step 1.
Yes.
And you
You-
have the CMake list, but I don't know what should I do.
You should here. You should set the minimum version of CMake.
So I copy that one.
You write this. So you want to set the CMake minimum version, well, CMake required version to 3.7 because that's the version we have. Are you okay?
Yes, sorry, he's bringing me.
Ah. Does everyone else have some issues modifying files or?
So 18 files.
Sorry, I it's possible that we start with I think it's over.
Okay, that's another question. So for the next steps, are you?
Can we force CMake to build even in the same steps? Like dash capital B,
Dash capital B, no, it doesn't build anything. When you type CMake dash capital B, what it does is it generates the build files into the directory, but then it doesn't build. You need to type CMake dash dash build and then the name of the build directory.
and if you want to force.
I guess there is an option. What I do is I just delete the directory and
What I was saying is that option is capital B in make.
capital B make.
Yeah, with make dash capital B it forces.
Okay.
So I was asking if there was the same with CMake. But that just removed it.
Well, I guess if I type CMake out, there will be some dash or something. Are you okay now? Okay. So the next to do projects to name your projects. It's in the same file.
The project is in the same part, in the same part.
Yeah.
Next,
Next.
sorry.
So the third is to add an executable. So now you have a name, you have a minimal version of CMake, you need to add an executable. So you tell CMake, okay, this is the program I want to build.
Okay. But that in which part should I edit it? Or where should I?
It's still in the same file. Yeah, every time there is a to-do and a number, they actually comments in the
Yeah,
files.
it sounds like I didn't find the third one was fine.
Yeah, sometimes they're not ordered. And with an executable, you need to specify the source file you need. Here there is only one, so it's easy, but sometimes you may have more than one sources, which is a big difference by with Make, where I advise you to have one rule per source file. Here you get the list all the source file you need for the executable. I lost you again.
Yes.
Yes. Okay, just here is a tutorial.
I mean,
So-
you could speak a bit more.
Oh, I speak too low. Okay, so here the thing is you name your executable. Here it's called tutorial,
Yeah.
and you list the source files you need. So here there is only one. It's called tutorial.cxx,
Yeah.
and it's a file that exists in step one. Okay.
Okay. But I understand it. I don't know if we should put the first part and the second one or both of them.
No, the first is just to give you the syntax of it. The second one is the one you have to write. Okay.
Thank you. I'm sorry for going so long.
No, it's okay. And okay, so to build and run, so here it's outside of the file. Is everyone has lost or
Actually,
yeah,
I don't get like to pass the first step.
first steps.
Yeah, the first step I failed to do one.
To the one.
I got an error message.
You get no, you can't get an error message.
Now I can
because
like
it's-
syntax error.
Yeah. What does? What's the line? It compiles the project. It compiles the project.
And then what the next is on like this.
When you say one like that.
Yeah.
That compiles the project.
And the first one, sorry,
This one,
yeah, the difference between the.
this one generates a build directory in which you have all the files you need to build the project. And then when you build it, it enters that directory and builds the project, compiles it.
To predefined template or is it a predefined template?
Predefined them. No, it actually copies a file structure of your source directory into the build directory, generates some new files, and then it's ready to be compiled.
So a couple of person, so maybe you can get back for a step. All those stuff to edit is within the file CMake list.txt. You need to open that file.
Yeah, the layout is already set, so you have the targets, where at least the name of the file you need to edit, and in that file there is a number for to do that needs to be edit. funzionalità del fichiero, ci sono all'interiore, à l'intérieur de ce dossier-là. Non, et donc, au moment d'exécuter ça, soit il faut faire un CD d'auteur.
Oui, ou tu fais un point.
Ou un dot slash.
Oui, oui, faire un point.
J'ai plus clean un dot slash. Parce que j'imagine que l'idée, c'est de bilan qui soit à l'intérieur. Oui, c'est ça. Mais ouais, en fait, moi, je disais, en faisant c'est un slash.
Ça dépend comment tu le fais, quoi.
Ah oui, c'est vrai.
Okay, so good remark here. The thing is, you need to be, you cannot be in the directory step one, you need to be outside of it when you put those comments here. So the build one directory should be side by side with the step one directory, not inside the step one directory. Is that clear? Or so the idea, I guess, is that you basically change directory to step one to edit the files, right? When you did that, well, I mean, it's okay that there's a problem with that, but I personally, when I did that, I did not do it that way. I edited the files from outside of step one directory. So if you are in step one directory, to move it up one, so you need to be outside of step one. So cd dot and be outside of it, and then you can so yeah, that's indeed missing slides. Are you with me now, or are people still lost? Are you okay now? Yeah. So, did you all manage to build and run your program? No?
C'est un logiciel qui se passe en Ok.
Parce que l'anglais, personnellement,
J'ai vu que parce que c'est un logiciel que j'ai dû installer en même temps des conférences.
Parce que déjà, c'est CMake, c'est pas OK. C'est vraiment super. Et je vérifie que c'est fichiers n'existent pas.
So the lab should work if you do the
J'ai essayé dans 5 jeux, c'est que j'allais faire un
Oui,
en fait, je
je
vais sur
l'ai
lancer après déjà mon dossier pour tester.
Okay, yeah. So
Il y a un
now,
moyen où je puisse savoir.
yeah, you see that you get a message being fired. So inside the now you have it was empty. But you can check with that LSP one.
Après, normalement, c'est
We have the.
Okay, are we there?
Ok. Non, mais là, je me suis balance. Là,
You can actually run the second.
Enfin, je suis sans regard, mais je suis sûre.
Which will be the binary.
Mais là, ouais.
No,
La aplicación del
Ça va arriver. Mais après, c'est juste pour savoir s'il y a d'autres serveurs où je peux utiliser. parce que-
Did you all manage to build and run? Yeah.
Mais si du coup, Make, il marche.
Yes.
Ouais.
What's the extent file with and what the other main files? I don't get it.
Can I have a bit of silence, please?
Parce que je donne une librairie et
Sorry, what?
When we like CMake,
Yes.
I guess the second line there, it creates a bunch of files. No, and what's like what is the main file that is created? I'm a bit confused about all these files.
So the idea is that you mean the second line after you make it here. So you mean CMake dash s
This one and the one after CMake.
Okay, so the CMake dash s1 dash b build instructs CMake to generate a build directory in which it will copy all the files it needs, the source files, the files that it generates. Well, I mean, for now there is not much that still. And among those generated files are the Makefile. Okay, and from that build directory, CMake will actually build the project. Will run it on the compiling of the project.
Okay, so the compiling happens in the third line.
Yeah, the last line of the first box is the compiler. So when you type CMake dash build and then the build directory, then the project will build.
Okay.
And after the program has been built, you can run it. So that's the last box. And here, as I said, it's a very simple program that just compute the square roots, and you use it as you would use in the program. So just here it's dots slash v1 slash tutorial, and then some arguments. Did you all reach this point, or is there still some issues? Okay, so but this is a minimal working example. So let's get to the more complicated things. So so far we know that we need to write some file that is to make something as a Makefile for Make, but here it's a CMake list.txt for CMake that instructs CMake that configures CMake to give it all the information it needs to actually build your project, and then everything is taken care by CMake itself. So now we want to move a little bit deeper into the C++ code. What I want is to change a line of the code, so to do 4 into the 5 tutorial.cxx in step 1. So I ask you to change that line where we use A to F, so the function on line 2, to this function. So it may not seem like much, but actually the difference is that the first one came into a C++ 98, so the version of C++ that came out in 1998, and replaced it by a feature that came out in the standard library in the 2011 C++ version. And there you should have an issue because the version of C++ is set to 98, but I force it to 98 to give you for the exercise. So this is to do 4. Don't forget to do 5 in the code. Okay. But is 5 units? Just removing a line. Yes. Wait, what's the? It's just to be clean. Okay. It's from the official tutorial, so I just followed.
You know, it's no issue if you keep it low.
Okay, once you've done that, I ask you to again build and compile as compile and run like this one, like we did before, so the same lines. Okay. So if it doesn't work, it's normal. I mean, that's exactly the point of this exercise. Okay. So it shouldn't work. If it works, then there is an issue. That's weird to say, but that's actually the case. So it doesn't work, and actually, if you read the output of the compiler, it would complain that it doesn't know that function. And this is exactly the point. So here, what we will do is that we will change. We will instruct CMake to use a newer version of subprojects. So this is in the file. The file CMake.txt is the 6th to do. Here, it's very simple actually. You just change 98 by 11 to set the version of C++ to a newer version. Yes, I know. C'est plus 1911. Okay, so now you should try and build your project again, and this time it should work. Okay. So again, it's all about versions. In order to have reproducible results, you need to keep your version somewhere. You just don't rely on default versions, otherwise at some point you may have some issues. So here's an example of how to set a variable. The syntax is very simple. Just set the null variable in whatever value there is. The CMake default variables are all prefixed with CMake underscore, so it's easy to recognize them. Which also means that you shouldn't define a variable that has CMake underscore. Makes sense, but sometimes it's surprising. So about versioning, let's go one step further. So it's very simple here, just modifying the project tutorial. Here we have a new argument, which is version, and then some number. So for your when you develop a project, it's always good to have a version that you stick to. So when you make some major changes, you move from one version to another, and you know what you did during the previous versions. Okay. So for a small project like that, it doesn't make much sense because I mean there will be version 2. That's a good practice to have, and CMake makes it especially easy since it's just one word and then some numbers.
Can you script that part? You take the versions number from a file or from like update notes or stuff like that?
Yes, that's the next slide.
Okay, sorry.
Okay, so to do 7 is just that, just modifying the line you're before. The good thing is that we can use some variables, some arguments that are defined into CMake into the code. And that is the point of the .h.in file that was before. So now we're going to use it. I want to use the version of my project inside of my project itself, for example, to print some help messages. Here, I have the .file, so the target now is tutorialconfig.h.in. The .in files are used to, they are ingested by CMake to produce their version without the .in. So here it will be converted into a file that is named tutorialconfig.h. Okay. And in that file, I have 2 lines. Okay, I don't even think it's to do. But actually, what I do is that this is C++ code, by the way. So define tutorial version measure, and then between the 2 hats, this is not C++ code. This is some placeholder that will be used by CMake to be replaced by the actual version. So we have version manager here will be 1 because here there's a first number, and the second line, so tutorial version minor will be 0. Okay. And there are lots of other variables that you can use inside of your code. You can set your own variables if you want. So it's an easy way to actually parameterize your project without even changing the source code. So that's a nice feature of CMake. And yeah, well, I call it templates. I don't like that term here because in C++ template means something else entirely. But the .h of in file is indeed a template of a header file that does not exist in the source code, but that will be generated in the build directory. That's why CMake creates a build directory, because the source by itself, if you use kind of funds, is not sufficient to build your project with a Makefile. But CMake generates everything you need if you insert it to, for example, here, the tutorial config.h does not exist in the source file, but it will exist in the build directory. That's why there are two steps. Okay. Everyone still with me? So now we produce the actual header. So, well, some of you got lost when I did some code like this. You shouldn't copy that, okay? I think I thought it was clear, but actually you shouldn't copy that, but just for some documentation. What you should copy, however, is that several blocks of code. That's the line I'm interested in. So as you can see, it's pretty straightforward. I want to configure the file tutorial config.h.in, and I give CMake the name I want to give it, which is tutorial config.h. Okay. So now, for now, we didn't change the source code more than just adding a new file. We don't use it in the .cxx. I asked you to build the projects and to check inside build one to see actually the content of tutorial config.h. So just a cat or an ML or vim or whatever, and you will see the content of the file is actually what I wanted. So I should define the major version, which is 1, and the minor version, which is 0, and that is a file generated by CMake. I didn't make it myself. I just inserted CMake to do it. Yes?
To do 8?
To do 8, yeah.
What are we doing? Why I couldn't follow the process.
Okay. So you were, that is good?
Yeah.
Okay, so what you do here is that you define the version of your project. Okay. So when I do that, what happens is that CMake will create some variables for me. So those variables are called tutorial_version major and tutorial_version minor. Okay? Those two are variables that are automatically made by CMake for me to use if I want.
So I don't have to do it manually in that thing.
In that?
What is to do 8?
To do 8
is just to do CMake.
Yeah. So just go into tutorial config.h.in and you should see that. Just 2 lines. Okay?
After doing the CMake.
No, before. Well, I mean, you can do CMake whenever you want.
Okay. Okay. Yes. Okay.
That's actually that file is not is empty, right? By default. Or not.
Here I have a. It doesn't look like that for me.
Yeah.
Oui, bah, il existe des compteurs.
Oh, yeah.
Oui, to do.
Yeah, okay, so this should be the content of your tutorial config.h.in.
So I configure that here.
Yeah.
And why do I do?
Why what? I didn't understand your question.
Why I'm copying it?
Are you asking me why you're copying it?
Yeah.
Yeah, to demonstrate the.
No. So the step 7 asks me to put a version, right? And the step 8, what we are demonstrating, what is the goal?
Here, the idea is to show you how I can use variables that are defined by CMake inside of source code, like .h files or even .c files if you want. So the idea is that CMake allows you to take some files that are suffixed by .in generally into their version where some placeholders, so for example, your version major, are replaced with their actual value. So you can modify the source code without modifying the source code somehow. So you instruct CMake to replace some variables by their actual value. You see the point? I can. You seem a bit skeptical about that, but I can assure you sometimes it's exactly what you want.
So basically, before you define the version major version, then you are creating a file that is a template for your source file. So tutorial config.h will be what is your source file. If you don't want to template, the same name config, template, you use the arrow-based tutorial version setting, which is a placeholder variable for the section. When you will build something, then when you will build the project, CMake will use the value from the CMake list. Will insert it in that code and generate a .h file with those placeholders replaced.
Is everyone with me now? So yeah, so the point here is that after you define that file, after you've written that those two lines in that file, CMake can generate the actual header file. And here what we need to, of course, we need to tell CMake to do it, otherwise we won't. Then you can do that by using the command configure file tutorial config.h.in, and then give it the new name it should have in the build directory. So the tutorial config.h. Do you all follow along, or are some people lost still? Don't hesitate to tell me. Okay. So if you build your project again, everything should build as usual because we don't use that file yet. But if you inspect the content of build one, you should see a new file now that is tutorial config.h. And if you inspect that file, you would see the two numbers, 1 and 0 for the major and minor versions. And why is that useful to us? You could ask, since we don't even use it so far. Well, the thing is, now we can do this. So we can include tutorial config.h, even though it's actually not present in the source code, and we can use it. So that's to tutorial.cxx, the 10th and 11th to-dos. So here, I include that .h file. That's basically just have two macros in it. And I can use those macros to change the version of my program, print it to the user so the user knows what version it is, without the need of me changing the version in several places of the code. Okay, so it may not look like much. Actually, it looks like a lot of trouble for not much. But the strength of that is that you have only one source of truth. For example, if I want to change some parameter in my program, and that parameter appears in different places of the code, I don't need to change it in all of those places. I can change it not from one config file, but directly from the CMake itself. So it's one file where I can parameterize all of my my projects. So it's kind of nice. I mean, when you use it, it's actually a lot easier than changing other config files. Okay, so after doing that, try and compile projects, and you should be able to see the version being printed. Well, why using it? You shouldn't, because there is still one thing missing. There's 12 to do, and this is actually including the file. So CMake also needs to know where the include directories are, and at this point here. So you indicate the path to the build directory.
Yeah, the technical machine. Because there's no. This was changed. See the portion
C'est pas long des projets. Non, il veut le nom de l'exécuteur. Ça, chez moi.
So there.
It's so see it's a specific type of system that contains definitions.
Step 9 formalisé.
Ça c'est longtemps.
Ouais, non, c'est bon. Il dit qu'il ne trouve pas le fichier de tutoriel config.h. C'est ça, mais c'est pas ça. Non, c'est pas ça. Ça y est.
So you so shift
Are you still? Are you okay, Oli? Okay. So now it should compile, and now you should see the version of your project being printed. So this is the end of step 1. So after step 1, you should be able now to configure files that you can include afterward and build basic project. Now, step 2 is about libraries and subprojects. So now this is where CMake shines actually, because for a very small project with 1 or 2 source files, it's actually kind of an overkill. But with large projects, it's actually really useful because well, now I'm in step 2. So if you're still in step 1, you can out of step 1 you're going to work in directory step 2. You can type tree. By the way, tree is a nice command if you want to have the file structure and see what's the structure of this step. So those 3 files, they should be familiar now because they are exactly the 3 same than in step 1. But now we have something new. It's the map functions. So it's a subdirectory in which there is some, well, let's say a library that we develop ourselves that implements the function we want. So here's some a bunch of mathematical functions. And I have square root functions here, and as you can see, there are 2 source files, .6x files, and 2 header files, and that is interesting. There you have another CMake list.txt. So what is nice about that is that you can write the configuration of one library and use it into another project, bigger project, so you can really split the development of libraries and your main projects in different tasks. They are independent from one another. Here, for simplicity, of course, everything is in the same directory, but it could be in completely different directories on your system. So how do I add the library? So now we have 2 different CMake lists .txt, so don't get confused here. We are not going to modify the main one that is on the in step 2, but the one that is in step 2/map functions. So this is the one we want to modify, and that's to do 1. Okay. And here, what we do is something a bit new. We want to add a library, so it's not like add executable, and but it kind of has the same syntax aside from the name of the function. So we want to name our library. Here it's called map functions. And we want to add the source code. Okay, so here's I have 2 here. It's map functions.cxx and mysquare.cxx. By the way, I have .cxx everywhere. Here it could be .c, .cp, .cc, whatever. But it's source code in C or C++. And the library by itself does not do much. It needs to be included and used by another program. So you can really think of a library as some sort of extension to add executable. That is already present in the main CMake list .txt of your project.
Is it a problem if I ever add executable in that one?
If you have?
If I ever add executables in that file?
Certainly not. No, it's not a problem, but then the executable will not be used as a library, of course.
Mm-hmm.
But you can
I
have some.
could have both.
You could have both, and then you can have both. But what you cannot have is 2 projects. You can define 2 different projects. So if you develop a library and you want to test it in a very small dummy project, you need to create a project specifically for that. Mm-hmm. So you cannot have some project something, including a library where there is CMake lists, projects, some other things. Okay, but yeah, you can add executable. Also because add executable is a way to test your program. So if you want to test your library, you need to add executable. But in order to work, you need to instruct CMake where to find library. Otherwise, of course, it does not know where to look. And how to link library. So if you're not familiar with the linking of the compiler, you're going to see that the initial one. So now we want to include the library. So we added the library earlier, and we want to include it. And we do that in the main CMake list.txt. So it's the second and third to do. 2 steps. First, I need to add a subdirectory. When I do that, I tell CMake, okay, I have a subdirectory. I want you to look into otherwise CMake will just ignore it. Okay, so you need to explicitly tell CMake to have a look in there. Here, your subdirectory is called map functions. So, and and then you need to include the directory. So this line already exists. It's the same we had during step 1, but here we use something more. We use the map functions directory in the include directories. So CMake knows that when it is looking for include files or header files to include, it has to go both the project binary here, so the project is generated in the build directory, and into the build / map functions directory where you have the header files that are copied from the source to the build directory. When you do that, you extend the search path over this. Okay. So far, so good. Or is there any questions, any issues? Yes.
You want us to do parallelly or
Ideally, I would like you to participate. Yes. But I'm
We need some time.
going to pass time. So where are you? Did you do that? Oh, no.
Yes.
So the second one, so the first one is the documentation. Okay. So that was in the library. Now, now in the main CMake list, this is what you need to add. So that's one and this one.
the third, the 2, 3, right? The target. And it should be the same one.
Normally, you should have a line like this already, but what is missing is the last dollar project source here / function / that part should be missing.
Can I put 2 lines targeting input directories?
The white space doesn't count, so you can.
No, I mean, having 2 full lines targeting the directory is one, and then the second one targeting the directory is the second.
Yeah. Actually,
You said I have to use only tab for the CMake tab.
no, that's for the Makefile. For the CMake, you can use spaces as well. Actually, looking at the time, I think I just skip a few slides, but yeah, well, the slides are on the Indeco websites. So feel free to continue the tutorial after the session, but I prefer to go fast through documents, otherwise we wouldn't have time to finish. Okay. Okay. So the idea here, after you include the library, is that you can use it in your projects. So inside of your project, you can include the headers that exist in the map function. So if you are familiar with C or C++, perhaps you would be used to have the full path on the include. Here you can skip that because CMake knows where to look for the different header files. Yes.
So if it's a library depend on other libraries, so the ordering, how did we take care of it? Like sometimes like you have to compile module 1, then the module 3 depend on the one, and then the module like 30 depend on the module other one. So the ordering.
Dependency.
Dependency.
I'm not sure I understand.
I mean, sometimes you compile some module that depends on other one. So
Okay.
first you have to compile the dependencies. So how will you take care of it here?
As Makefile would do.
Automatically.
So if there is a newer version of the source code, it will recompile it. If not, if the library or the executable is newer than the source, then it will not. I don't know if I answered your question.
Yeah.
Okay, so now CMake knows where to look for your library, so you can include it as a root. Well, as you would if you were on the same place, which is nice because it means you can be wherever you want on the system. And now I can use functions I define in that library. So the map functions colon is the namespace of that library. So there is some problems because if you only do that, the CMake does not build everything it needs because it does not know it has to. So you need to specify CMake that actually needs to build the library directly. And to do that, to build and to link the library. To do that, we need to link all the paths together. Because sometimes you can build different libraries without linking them. We want to do that. Here the point is to link the map functions library to your executable. Okay, so this is after the compiling itself. So all the binary code exists here. Now what you want to do is to link them together. So the different binary files can see each other and work together. Okay. So here, let's try to link the library to your projects. So far we know you've seen a cleaner way to organize a bit more complex projects. You can have a lot of different libraries that you develop along your years of research, and then when you want to build some new program, you don't have to code again all your libraries or copy paste full directories of code from one place to another. You can use them as CMake modules to be included everywhere in them, basically. So it saves you a huge amount of time in terms of development. Well, we know we have a better understanding how the compiling process works. So first, binary is what the code is translated into binary, and then it's linked together. And what comes next is options and conditionals. So in CMake, you can compile part of your code depending on some conditions. You can set some options that you want to tune compile time for your program. For example, if you want to use a library or another, for some reasons, for example, if you want to use a PyTorch and TensorFlow that you want to switch between the two, you can do it. So to define options like defining a variable, it's this syntax. So in this step, we define use my math, that is simple option that tells CMake whether or not you want to use your own library or if you want to rely on the standard library. And you can set that as you can send that in the terminal before compiling, and this happens during the generation of the build to retrieve. So that's the first line of the last box of code. A code that here is no longer CMake. It's CMake. CMake has a nice interface where you can set the option in a more user-friendly way. And you can switch the option I use my mic to on or off. And once that option is defined, you can continue. Well, you can use it in CMake to tell CMake what to do with it. So this is an example. So this is in CMake. So in CMake you have if else. Well, if else with this syntax if and if. And here I basically I use my option to instruct the code, actually to tell the code that I want to use one library or another, and this is done in the code using this. If you're familiar with C, this should not. Well, this should be familiar. It's using macro, but here I include some other files if some macro is defined. So here use my math is defined only if I set the option in the CMake, and I can include in my own the file of my own library. If I don't use my map, of course this file will not be available, and so this would be an error. So it's a way to insert the C++ compiler that I don't want to include it if if the variable the use my map is not defined. I do the same directly in the code. So here's two different way to use square roots. One coming from my own library, another from the standard library. And again, this is from CMake, so you don't need to modify the code. The code is written such that CMake take care of everything. And it also allows you to skip unnecessary compiling. If you don't need to use a library that is not compiled, it will simply not compile it at all. Okay. Let's skip this. Okay, there is one thing though I really want to tell you about. It's a single part of step 2. So step 2 was about you develop your own library and you want to include it into a project. Now what's about you want to include a library that exists in the cluster? I've taken the example of Eigen. Eigen is a kind of an NumPy, Python NumPy, but for C++, so it's a mathematical library that allows you to have multidimensional arrays in C++. It's very powerful. I want to use it. Okay, I have basically two ways of doing it. Either I go get the source code on GitHub and I clone it locally and I use it locally. That would work, but that's definitely not the right way to do it. The right way to do it is to well, use CMake for that. So in CMake, you just need this line. You specify the version first. So here I want to use version 3, version 3.4, and I want it. I want it. It needs to be required. So I specify CMake that I cannot work without it. And yes, so that's how I link that library with my my executable. So I need to specify the component of the library. Here there's only one. It's Eigen. If you compile it like that, if you try to build it like that, it won't work. It won't work because I haven't loaded the that library yet. So if I load it, if I load Eigen, and then I configure my projects and I build it, then it would work, and I have access to Eigen without even the need to locate the library. And so here it's me using the library inside of the code to demonstrate it actually works because much more than just coding library and adding CMake files. Well, we are at the end of the session, so just a few words on that. So you can also install and test. So for now, every time you need to run your program, you need to type / the path to your program in order to run it. You can install it so that you don't need to do it. You can just type the name of your program and it runs. So CMake allows you to do that too. So it looks a lot like a build, except okay, so you see that command? It looks a lot like the build command, last one. CMake -- install instead of build, and you just after building the code, and you just move the right executable header files and libraries to the right places. On the cluster, you cannot install program system wide, so of course you will not be able to, but you can install it on the .local of your own directory, and it works as it was installed locally. Globally, but only for you to install it. So yeah, then about testing, I won't cover that because I have out of time. But this is what looks the testing of the CMake. So you can run some automated tests on CMake, which is pretty neat because you can every time you compile, you can run some tests and make sure that you haven't broken anything in the program, because it's very easy to develop something new and then break some previous feature and don't realize it. So with tests, you can test everything still runs. You can also define some CMake function inside of CMake. Everything I skip here is also on the tutorial, so if you're interested. If you're interested, don't hesitate to go check the tutorial online. It's very well made. If you feel the need to, of course. That's the end of this session. It's the first time I give the session, so I think there are some few things to modify regarding the interactive parts. But I hope you actually understand a little bit more how to automate some compiling process using Makefile and CMake. That's it.